portfolio.
And you have any development experience, or do you manage any development team, software development or application development?
Mm. No, no, I'm not into development.
Okay, okay, thanks, Lee. Who's next? Anybody else?
No, only one young.
Okay, great. Thanks, Lee. Study, please let us know if anytime you have any difficulties how to see the screen, or if you are missing us, missing my voice, anything, please let me know.
Sure.
Sure. Thanks. Okay. Now, when we say security engineering, what it is. So, first of all, what I feel, probably I have to adjust my content lot, because most of you are from managerial side, and this course is more into how we can build secure software. But most of us are not building software, so there was a point of knowing what is how to build secure software. But we will connect some of them, because if you want to pursue your career in cyber security, probably this is also a major part of that. And when you are a manager, you are when you manage a big team, and that high who are developers or who are creating softwares, probably that time it will be very useful. And also, probably some of you will be a CISO or CISO. Like, you have to be. I have to send my resume that time. Okay, so that time it is, of course, it is required. And if anybody of you are planning for CISSP or GISP, in that case, this is we are covering two modules from CISSP. One is the security engineering module, module 3. Sorry, security architecture, module 3, and module 7, which is security development. Okay. What's happening? Okay, we have two more folks. Can you please introduce yourselves?
Yes, my name is Richard. I work in TRIM04. I'm kind of like a fintech, not a company tech.
Okay. And sir, you?
Hi, I'm Pranay. I work for Single. I'm offering architect to the solution.
Okay. And are you from the technical background, and you are doing your technical, like managing the development teams or something?
Yes.
Great. You can correct me better than others, because the entire course is like that. Okay. And also in this course, we will learn one more thing, which is cryptography. Cryptography is mathematics, and why this is very important for us. The moment we go somewhere and we say we are from the security background, people would try to understand, okay, these guys must be knowing cryptography, because that is kind of the silver bullet, or that is the magic wand all the security engineers are using, or the security folks are using. Every time you are listening about the certificate headers, there are HTTPS, all these things you are listening. But what is the magic behind that? What is happening inside? What is happening in the background? I think we all of us need to know a little bit about that. Again, that is a technical one, a very highly mathematical one also. I will try to make it as light as possible for you guys. But a little bit mathematics we really cannot escape, because it is engineering, this is a science. So we have to understand the mathematics behind that. We'll cover that one. And let's see, okay. Because that is kind of I believe cryptography is something every person who is associated into information security must know. So that's why we will cover cryptography as well. And again, for CISSP, it is a it is a very major chunk of the thing that you can expect almost 50 to 20% questions from cryptography. Okay. Yeah, I have already introduced myself. I did my PhD from IIT Kharagpur, and I have published quite a few research papers, some patents. Okay, now this is not updated. I have filed now 5 patents, and yeah, I that's pretty much everything. And yeah, there is some. Whether is it working? You can see it.
Oh, that's TV, so we cannot see it live.
Okay, it's a TV, right? Okay, so I'm using my hand. Okay, safe code wasp and start. I will talk about that. These are different forums, and that's all.
Quite a lot.
Not quite a lot. I am very lazy in fact. In fact, I did my PhD because I was so lazy. I did not apply for any company. I was so lazy in that.
You think you're lazy and so much imagination.
Lazy people can do a lot of
We are dead. We are dinosaur. Like a dinosaur.
Okay. Now let us start with security engineering. What is civil engineering?
Building up.
Yes, it's a science and art and technology on how to build building, roads, bridges, and all, right? What is mechanical engineering? It's the technology to deal with machines, to create new machines. What is security engineering? How we can build security? How we can? What are the technical side? What are the techniques behind creating new security? Right. So that is security engineering. And when we say security engineering, of course, it is again the science and art behind creating secure systems. Now I am coming to what is security system. Before that, quickly, I probably already said that the expectation that what we are going to deal in this course, we will learn how to create secure systems. Uh, Done with the reading. Anyway, I will share the slides. So there are a lot of text. Many of the slides have a lot of text. Don't worry. When I share these slides, you can go through that. And the things you do not know, you can always Google that. Please discuss with me. It's not a one-way knowledge transfer. It is not like that. And whenever you are getting a new idea or whatever I am telling you, when you get some new idea, please pick up, please discuss it with us. That will help all of us to grow. Okay? Because I am also learning. And what was the last book? Yeah, as I said, I do not know everything. I'm just giving you some points. I will create a mind map that what all these things, different terminologies you will hear, different jargons you will hear either from this class or other class or in the industry. Lot of jargons will keep on coming. So I will try to create a mind map of those jargons, what is what. And the detail you can always go and Google, find it anywhere else. So everything I really don't need to explain, right? So this is how we will evaluate attendance, stain, and we'll have a practical group discussion session here, and we'll have the MCQ, which is like the major chunk of this. We'll conduct a quiz on the last day, and yes, there will be some assignments, some assignments that do some are very technical, some are anyway. We'll figure out how we can adjust those assignments so that everybody of you can participate there. I really don't want to set an assignment that people who never coded. So, I'm not going to ask you write a code. Okay? So
Of course, question in this. So
yeah.
when we say MCQ, that's a final exam.
Yes.
Okay. And for practical, is there required for the system or it's going to be like group?
Yeah, it's you can you have to submit the thing. There are a few things I will ask you to submit. You have to submit it in the LMS. And in my course, there will be like every day when we'll discuss about these things. There are three things you can think of. One is a think security, how we can think about security, how we can think to create a new secure system. And then the build security, that means get your hands dirty and really get into that, the implementation part. And the redefine security is a lighter one. That means how what is the future of this thing? What is the new thing that is coming up? All these things we will discuss. So this is something. Thing one, think security is something like I really need a more participation from you guys. It is a thinking exercise. So it's more discussion, more participation, and I really want you to be attentive in that when we are discussing about that. Build security is hands-on anyway. It is fun if you can understand what is happening, then only it is fun. So I will try to help you in that one. And after that, you can run the show by your own. And redefine security is a lighter one when it is more of a discussion session, the new things, probably some interesting things like DevSecOps. You said right, DevSecOps. You said. Yeah. So DevSecOps is something we'll discuss about IoT security, about quantum cryptography. So once we learn cryptography, what is it? Because these words are coming, right? Quantum cryptography. Now, when you are a security professional in the market, probably quantum security, what it is, whether it is to eat, something to eat or something to wear, you need to know, right? So those are the things we'll discuss. Okay. So this is today's menu card. Okay. Let's see how much we can cover here. Sorry. So when we say security mindset, just imagine like this is a story, not a real one. So I had a drawer and I want to keep some valuable things inside that. But you see, this is the putting a lock is very difficult here. So I went to a carpenter. Carpenter created a beautiful things like this, which perfectly works. I can put it and I can put a lock here. No problem. Right? So that carpenter is our engineer, the developer. I am somebody who is giving a requirement, right? So this is my requirement. I want this drawer to be secure. I want to put some valuables here. So is it secure?
Master, you can remove that three screws and take it.
Yes. Yes. Good. That is one. Any?
It is comparatively secure, so the threat is more vulnerable, the higher one.
Yes. You can just put it down and take whatever you want.
Okay.
Right? So security mindset is something. So anybody really cannot do security. You just cannot ask somebody, hey, just secure my system. This is the software I want, just secure it. It needs some understanding, it needs some thought, and it needs a mindset. The moment I see it, I would okay, I can access this one. This is not a problem. So that's the way the hackers think. Okay. And hacking is nothing but this one. Right? This is a hacking. Now, quickly, what is security? We're talking about security. What is security?
Finding a way to secure something valuable.
How do you mean by secure?
So it's turning your
Making sure
valuables.
it doesn't go to the wrong hand and use any means.
Okay, wrong hand. That means it should go, the asset, the valuables should go only to the person who I want to or who is legit, not to others. That is what security. It should not go to the wrong hand, it should not go to the wrong person. And the asset might be anything. Asset might be my gold jewelry, it might be my money, it might be my home, it might be information. Right? And why it is very difficult to achieve security. Any thought why security is very difficult to achieve?
There are million ways to grasp something which is thought to be secure.
Mhm.
If we kill that million choices, they will find million one first choice.
But is there any way that we can plug off all the possible things?
No.
Cannot be more.
Unless we make it sure that.
So whatever we do, some more creative person will be there in the world who would abuse this, right? Okay. Anything else? But why that is not possible?
Security has a trade-off with performance and
Okay.
cost effectiveness.
Very good point. Yes.
It is difficult to do 100% secure
Yes.
system.
So we got 2 points. One is it's we really cannot achieve security because there will be some creative person more than me. Okay. And secondly, you said it is
Trade-off.
trade-off. Yeah. If the best way to secure my laptop is just plug don't connect to the internet or even don't switch it on. It is always secure. All the information is secure. But that is not what we want. Anything else? Or go back to the first point, there will be a way to abuse the system. Why? Why we really cannot protect the system fully?
So in simple terms, like if there is a door where you have to go out and come in, which I'm talking about the network side of it, you can't control it. I mean, there is always a loophole.
But why? The question is why? Why we can do that? Why we can achieve something like 2 plus 2 is 4, that is always there. But here the problem is there is no measurement of security. It's not a science at all. How can we measure security? This is 100% secure. And we cannot we cannot measure that percentage. And there is no formula about that. There is no modeling. Right? So it doesn't follow any natural rules. There are scientists, there are a lot of people doing their PhDs, there are a lot of people who are researching on that, whether we can really achieve that 100% security, how we can quantify security, how we can model security. Anytime you hear this word, model something, what is that? Usually in information system, when we say something, I am modeling security, I am modeling a system, I am modeling this thing or whatever, that means I am trying to find out a formula. Model is nothing but a formula, mathematical formula, right? But we cannot model security fully. We tried to achieve something. That's what we are right now discussing, whatever we have achieved. But we know there are a lot of things beyond that which we could not model. That's why. Make sense? And how does it affect? We know we are living in the digital era. We know how does it affect. Right? And security mindset, what it is, I just explained in the previous slide. What is security mindset? How the hackers think. And this one I just discussed. There is no measure of security, but still we have to achieve something because when we are in the industry, we are producing software or we are producing systems or hardwares. We have to achieve a standard, and when we are calling something the standard, that means everybody is following at least up to that. So there has to be a way to measure security at least to some extent. It is not fully workable solution, but at least when I am saying I am 30% secure and you are saying you are 40% secure, we should have the common measurement procedure, right? Even we know that measurement doesn't mean much, but at least we are following, I am following some process, you are following the same process, then we can compare whether your software is more secure than mine. That's why there is something that we'll discuss. And the last, but not the least, how to secure a system. That if we know that magic formula, if we can model that, every problem related to the cyber world will be solved. But we do not know. As long as we do not know, my job is secure, your job is secure.
Yeah, it is the coffee discussion. How to secure a system. Let's make everything open. Nothing to.
Okay, but will that, like, in that case, it is fine when everybody of us want to be open. We do not have anything to hide. But in a practical scenario, it's not possible, right? The payroll department really doesn't want their payroll Excel sheet to be open to everybody, right?
That's a mindset.
That's a mindset, yes,
Yeah.
but there are something really, the information It's good to everybody knows all the information, but it is really not a practical solution. At least the society we have built, the way we have evolved. So it's really not possible. In that case, the society will collapse. Like if the defense, all the defense secrets are out in the market, it really there is no defense in that case. The another security will be affected. The nation security will be affected, right? So it is, yes, that is good. So that's why open source and everything is good. Open source are more secure. Actually, you are right. Open source software, I believe, that is the, again, that is a belief. There is no proof for that. But I usually am much more comfortable to using open source software because there are 1,000 eyes who has already seen it. There are 1,000 people who have already tried to abuse this thing and they could not do. And if they did, they at least created a raise a ticket for them, right? So that's why I believe that is much more secure.
So the view here, when we keep everything open, then the confidentiality will try and
Yes, I'm coming to that. Yes, that is all of us already know that there is a threat. So that's how we have tried to model information security. Okay. And as we discussed, perfect security does not exist. Now, before coming to the information systems and all those boring technical stuffs, let us find, I have a house, beautiful one. No, no, my actual house is not like this, don't worry. Or don't think that I am living in this house in Bangalore. Yeah, so there is a house. Now I want to secure this house. Everybody wants their house to be secure. Now, if as a normal user or a normal resident of this house, a normal person, how do you approach to secure your house? Then after that I will explain how a engineer, security engineer will approach.
The first thing is put locks on everything.
Yes, good.
I take in community.
Yes.
We want security.
Boundaries and all security.
Securing layers basically. So perimeter.
Yeah, now you are thinking actually in a way as security engineers think.
Much beyond that also.
Randomly, what we think after the house is built, not before that. After the house is built, we go, okay, put a lock here. Somebody can enter from there. Somebody can go break this glass window and come. All these things we think, and then we try to plug all these things. And we really do not have a big checklist. We don't work like that. We usually.
Nowadays, our apartments are coming with full checklist only. We have no access control and glass plate.
Yes, because now it is getting streamlined.
Yes.
Now, in fact, for the house also, the architect are also concerned when they are building the house. That time only they are thinking, okay, we have to think about the security as well. It's not only a beautiful house I have to make. I have to make everything, the usability, the security, everything, and that's why that checklist is coming. So, do you understand that checklist has to be created in the beginning, not after I build the house. When the architect is starting, like architect has started drawing it on a worksheet, that time only we will have to think, okay, these are the things I have to take care of. So for security engineers, we usually think, okay, okay. For the security engineers, we always try to think, what are the ways that the security can be abused? What are the how can somebody come and compromise my security? That is the very beginning. The architect, when the architect starts, here it is the building. When the architect starts creating the software, that time we need to think of that. And when we think, how would we think? I will come to that. That is called threat modeling. They call threat modeling. You have heard this term. At least all of you have heard this term in the industry. And it's like the people who do threat modeling, like people think, okay, they must be some alien guys who knows some rocket science, but it is not. It is nothing but thinking in that direction, having a checklist and figure out whether everything is intact with that checklist or not. That's what they do. But how to create that checklist? That is the challenge. If I give you that checklist, anybody can do that. Now the challenge for a threat model engineer or threat modeler is how to create that. because your threat model might not be my threat model. What you think as a security, what you think as an asset, I might not think. Like, yeah, I have an empty house, then the entire notion of security is different. And if I want to keep some gold jewelry inside my house, then I will think a different direction, right? So that's the thing. The very beginning, we have to understand who are going to use this, what are the asset I have, how much value of the asset, and who are the attackers. And then we have to find out how we can create security around it. That is what we call threat model.
Can I have?
Sure, sure.
So when you use threat modeling, you also include assessment or?
No. Threat model usually starts before the code is ready. Even the developer starts writing the code. Before that, the threat modeling should be complete, because the threat modeling result, that checklist should go to the developers. The developer will see, okay, these are the things I have to follow in my code. That's why before writing the code, we should be ready with the threat modeling. But that hardly happens in industry, because anything that does not have any deliverable output doesn't have much value in industry. All of us know this pain, right? It's a pain for us. We know how difficult it is to convince the people who are taking the decision with something very abstract, because this does not have any output. We cannot tell them that, okay, this is the value, this is the money you are saving with this. We do not have that measurement.
ROI is the biggest problem.
ROI is the biggest problem, but security, how can you measure the security ROI? It's very difficult.
Both security and analytics.
Yeah, so only thing we can do, we have to create some horror stories around the market about the breach, how much people had to pay for fine, or what is the effect of a data breach. All these horror stories we have to cook up and we have to convince people. There's a typical trick we follow, and we all of us here know that, right? We do that, right? Now we hear a lot of terms: vulnerability, threat, risk. What are they? Before going to actual core information security and all, I'm just trying to set up the explain some of the things with very natural things, that is you don't need to go to that much in detail of the technical stuff. So if you can correlate that house with the information system, then you are done. So at least you will in any of the meeting you can, or any of the discussion, you can follow up what is happening, what the other guy is saying. That's why I'm just going to more into the practical examples, not with the hands-on information systems. So vulnerability, threat, risk, attack. What are these? So is there any difference? We very often hear these terms, right? Is there a difference between weakness and vulnerability?
Yes.
What is that?
It can be exploited,
Then what is an exploit?
taking advantage of vulnerability.
Okay. And what is an attack?
All of them.
Threat detection. Threat detection is a type.
Okay.
Attack is with bad intention to steal the data. But if vulnerability or weakness is there, internally also we can exploit it, but doesn't mean we are stealing the data.
Okay.
So thought process is different in both the cases.
Yes, but effect is very similar. If that application is market, if you open your application, the vulnerable application to the public, whether I have bad intention to steal that or not, if I abuse, you are gone, right?
But attack usually will happen from outside.
Yes, yes, there are inside attacks as well, and now we hear another term: zero trust architecture. That means I don't trust anyone. It is insider or outsider or the root. I don't trust anyone. That's if you build an architecture, if you build a system around this idea, this is called zero trust architecture. And that is one sentence definition of this. You don't really need to know much more than that if you really were, unless you want to create a zero trust architecture design. Okay, but that is, at least anywhere you hear this thing, zero trust architecture means I don't trust anybody. That's the idea behind this. The entire design is built on that. Okay. So let us quickly go through these things. What are threat, vulnerability, attack, risk, and what else I just said? Weakness. Okay. Okay. What is a threat? First, let us start with what is a threat. Threat and risk. These two are very close down. Threat and risk. Now, how can you when somebody says I have a threat in my system, and somebody says I have a risk in my system? What is the difference between these two terms of these two sentences?
If any vulnerability is there in the system or control, then it will get exploited. That is the threat. Somebody can exploit that.
Okay. Let us forget about this information
For
system.
house,
Just
for
for a
house,
house. Yeah.
for house, we have a window, but there is no lock.
Mhm.
So lock is not there. It is a vulnerability.
Okay.
Existing window system. Somebody could come inside is a threat, and it will stole some valuable. It is a risk.
Great. Great. So threat might be burglary. That is the threat. But that does not mean that there will be some the theft has happened or will happen. The threat is there, but I can address those threats. I can put a lock. The threat is still there. Threat is in generic one. Threat of burglary is still there, but I have used some mechanism or some technical, some security controls against that threat, right? And risk is what are the value of the items that is stolen. Risk is usually converted into dollar value. That's why management is more happy to get the risk report rather than the threat report. Because at the end of the risk report, it says this dollar value is on stake. Now you take your decision. So there might be threat of burglary, but if I don't put anything, it is an empty house, there is no risk. In that case, there is no point of spending money on that on securing that house, right? Like, a little bit security is there. Otherwise, some homeless people will come and start staying there. That is a different kind of threat. If I have think of that threat, but the main thing is I should not spend money, even though there is a threat, even though there is a vulnerability. I might not. That might be a business decision that we are not going to spend money on this. We might not fix it because yeah, public information. But if somebody changes the public information, that is a threat. So confidentiality related to the public information is a threat, but not a risk. But integrity is right. Similarly, if it is an internal facing application which is used by very few people, then even though it has a severe or critical vulnerability, I might think, okay, this is used by only 4 5 guys. I know them. What's the point of spending money and time and effort or to keep this? So we have to understand in that direction that threat is bad, but that might not be that might not put risk into them. That is the difference between risk and threat. Clear? Okay. Now come to weakness and vulnerability. First of all, vulnerability is a weakness. Weakness is the superset, and vulnerability is the subset. Okay. So weakness is no lock at the main door. That leads to a vulnerability that an attacker can push the door and enter to the house. Okay. So this is more of a, and in the information system, I'm just speaking in the information system. So you know about these things, CWE,
Yes.
and you also know CVE. So this is weakness enumeration, this is vulnerability enumeration, right? Everybody of you connect with me because this thing already covered in some of the previous courses, I guess, right?
Yeah, we agree.
Okay. In that case, all of you know. Okay. So weakness, what is the weakness? Weakness might be buffer overflow. I think it is 118 if I'm not wrong. This is a weakness, is a buffer overflow. Or let's take a simpler example, SQL injection. SQL injection is the weakness. But when we say this particular Oracle, some particular version, I don't know, X.Y, this version has SQL injection, then it becomes a vulnerability. And every vulnerability will have a CW, of course, because but vulnerability says this particular version of this software, this version will have this weakness. That is called vulnerability. But weakness is buffer or SQL injection. It is a class of the thing. Got it? Clear? These things are already known to you, or you want me to explain these things? Please let me know. Because anyway, I am adjusting the course content. I am not delivering what I have.
Comes, but the refresher is good.
Okay, and okay, and the difference is also was it known to you, or you just now trying to connect, or it's becoming more clear?
More clear.
Great, great. Let me know if I am repeating something that is already known to you, or already it has been covered in some other courses. Please let me know that.
But refresher will be.
But refresher.
So
Yeah, in that case, we'll only keep on refreshing things. We'll not do the new thing. Okay. Tell me why a system fails. Any system, be a house, be a car, be a information system. Why a system fails? There are three ways a system can fail. One is reliability, another is usability, another is security. Reliability, it might crash. My car, I have taken my car and it just for some reason the brake was not working. This is the reliability issue. Usability is something that is not usable for me. The brake is when it was stopped, that time the brake was gone, or the brake is always applied. Yes, I need to apply the brake when it is required, but when it is not required, that time also if the car is on brake or my handbrake is so jammed I cannot take it out from the braking position, then it's a problem. That is a usability issue. And security, somebody deliberately do that. But when we model security around the system, we usually consider all these three together. Because any reliability issue or usability issue or security issue together can lead to a security problem. If there is a reliability issue, people can abuse that reliability issue into a security issue. That's why we model security, reliability, and usability together and consider them as a security model.
The system fail is based on the security perspective, right? Or generic system fail.
Sorry?
So this, why the system fails, we are talking only from a security perspective or overall?
Overall, because the reliability is the overall failure.
But what, we are not covering the external factors, right? So if that's the case.
Security is the external factor, is not
Like natural disaster and all this, so we don't consider that.
Yes, that actually part of reliability. Actually, natural disaster usability, when you model reliability, so not usability, reliability, that time we usually say the car there is flood. How much flood my car engine will survive? That actually the engineers, the mechanical engineers who has created the engine, they have thought of. There is a threshold. They always put a threshold. For everything, there is a threshold. This much of water level it can survive. This much of heat it can survive. This much of cold it can survive, right? So that is part of the reliability. In fact, reliability engineering is a different discipline, if you know. Okay. And reliability engineers usually deal with all these things, all the limiting conditions they usually deal with. Okay. Okay. Now, so far we understand that we have to understand these things whenever we are trying to secure something, and from the very beginning, in the threat modeling perspective, we have to understand what are the assets to protect, what are the threats, who are the adversaries. These three things we have to understand. Then how we can find the risk, we can find the value of the asset and the probability of the threat. That is the risk. we have to define, in the very beginning, we have to define that this much security we want. We really like, I am creating an internal facing of the application, it really doesn't need to follow all the like CMMI level 5 level kind of thing, right? It really doesn't need to follow all the, like it is, nobody is going to break it with using quantum cryptography. I don't need to make it quantum resilient system. It's an internal facing application. Even if it is a external facing application, maybe the bank website, the bank portal, the PCI DSS, anything which is dealing with PCI DSS, they might have, they have set a different kind of security goals. But when I am just creating something else, like maybe just a static website, my home page, that doesn't require that one, right? So, and when something is dealing with the health system, not only health information, that is part of HIPAA. But I'm talking about when there are a lot of IoT devices now we have, which is actually creating, like the doctors are using, say the ECG machine that the hospital is using. Now all the ECG machine that these hospitals have, they are connected to internet. They are at least to their internal lab. That's why the doctor sitting in their chamber can see the ECG. They can monitor the ECG. There, how much security we want? Actually, we need a lot of security, but the problem is, if you go to any of the hospital and if you try to hack it, it's very easy. In fact, I did. I was there in one of the hospital here. In fact, I was admitted there, and I was. It was a boring time in hospital, right? So I tried to hack their internal system, and it is very easy. It's just a keyboard. Okay. And this hospital actually is boasting like we are fully digital things. It's all these things. They boast a lot about that. Okay. So it,
99% of hospitals are not secure.
Yeah.
at least that's what I know. Few of the reports are also saying that because they are doctors. They are not security expert, nor they are computer engineers also. They are doctors. They really do not know that how these things can be abused by using it.
But they need to hire an external person to do this.
They need to, again, that requires money. Now the corporate hospitals, the management, they would ask, come on, if I need to spend 1 crore here, I will actually hire two doctors, two good doctors. Right? That's what
They
the-
say they tell like
Somebody has to come up with information print somewhere, right? And only-
Yeah, they said, what's the problem? Like, who is going to do that?
Probably should have shared that report.
But this is business. After all, somebody is doing business. They will take the decision whether this is really he is going to concern of or not. In fact, there was a very famous incident happened in the black hat. Somebody actually showed that how he can yeah, use just a single magnet. He can actually stop a pacemaker. Pacemaker is what? It is nothing but an electric pulse, right? Whenever it is an electric pulse, it creates a magnetic field around it. I have a very good magnet. I just pass from that, like the guy who is with the pacemaker is standing here. I just, with a very strong magnet, I just go and stand there. If I know how to place the magnet and what is the magnetic field I require, if I just calculate that one, this guy is gone. His pacemaker just stops.
Hack also.
It's a hack. It's a hack. In fact, there is an incident in Australia. Somebody killed this way, and he openly said, "Yes, I killed it. Now prove it in the court. I killed it." It's not a weapon. I can take a magnet and stand beside
There
somebody.
is one more crime to it, like it was a Bluetooth control thing also for the course.
Yes.
Somebody hacked it, called him that I have already hacked you. You pay this much, then only I'll release you. His pacemaker was hacked by. Definitely.
But that's again, it's submission as well as there is Indian position. Intentional harm.
It's intentional. Yes, it is intentional. It is intentional. Now this guy did it. Now, like, how you can prove? Like, when he is in the court, I said, I did not know that the magnet is harmful to this guy. Yes, I said in the blog, that is because that is a blog, that is not a legal document. Now I am in the court, I am saying that I did not know anything. I just took the magnet and stamped it. because blog is not a legal document.
The lawyer was bad, sir. It is like I'm keeping a knife and I'm just holding it, and he came and died. You can't say like that.
I cannot say like that. So what did he say?
So example, like I have a knife, a person is coming, so he comes and he pokes by himself. Then I can't say that I was just holding the knife, I didn't know he came and died by himself.
But knife is weapon, no?
That is weapon, yes, because magnet is that is again in the code. But this thing happened, and that's why Australia had to change like pass a bill on that, because these kind of things also now under their legal system. But initially it was not there. It happened, and even in the group that insulin pump can be hacked. So this is in the consumer thing, and in if you go to the hospital, you can actually access other patients' ECG report. You can access their almost everything you can access, and even the Wi-Fi, their local network Wi-Fi that has so poor password, you can just it is just 2 minutes it will take to get that password. So it's so simple. In fact, at least 2-3 times I have seen that, but I'm not legally authorized to do that. Okay, so that's why, of course, nobody has appointed me to come to do the penetration testing there. It will be, I'll be very happy to do that, but unfortunately nobody does. But it happens. It happens. So yeah, we were here. Why? What is the policy or the goal? So the business owner need to define the policy and the goals. Sometimes it is the business owner. Sometimes it is the industry standards. Sometimes it is the law enforcement authority or the legal. They create. Okay, if you are dealing with credit card information, you have to follow PCI DSS. Right. So this is a boundary condition of our security. We all know this is the CIA triad. So now after like really if we want to know what is information security, we have modeled it in this way. Again, this is not a foolproof model. CIA is good. That is how we have the computer scientists or the computer engineers have found that okay, if we just secure these three things, we will call the entire system secure. That's how we are modeling. The information system is secure if we can secure confidentiality, integrity, and availability. There are thousand other parameters, but somehow it is mathematically proven that if these three are taken care of, rest of the things will automatically be taken care of. Okay, that's how mathematically. In fact, if you really want to know what is the mathematics behind that, there are few things you can go. Bell-LaPadula model, if you have heard about this, a Chinese wall model. So you must be thinking what this is. This is a simple thing. Why they are calling this, like why this is a new model? They are calling a new model. They are coming up with this. Why? Because there is a mathematics. Usually we do the formal verification for verifying something. Formal verification is again a mathematical verification for something. And when we call something formal verification, it is always in a formal language. And those things that you learn in your Chinese world model or Bell LaPadula model, those are actually those formal models. Okay. So I'm not well, like I don't think you guys ever have had a chance to go to a class of formal modeling or the formal verification, but that is a completely separate section of computer engineering or computer science, that is not computer engineering, computer science. And probably most of the computer research related to the computer science is happening in that field. Because if you want to prove something, if you want to say like this simple thing, confidentiality, integrity, and availability equals to security. Somebody told that. He had to prove it. And for proving that one, you need to know formal verification, formal modeling, and model checking. That's how we can prove something. Okay. Okay. But yes, this actually does not work for CPS system and all. CIA, like if it is a CPS system, like cyber physical system, that time it is not only confidentiality, integrity, and availability. There are some new attack surfaces. That means there are some new things that the attackers can exploit. Okay. What's happening? Hi, Srini. You are like any problem with you there? You're fine, fine so far. Just want to check with you. Okay. So security is all about prevention, detection, and response. Again, that is formally proven. If we do these three things related to any security, not only information security, any security, these are the three ways we can achieve security: prevention, detection, and response. Detection, you know already. Probably you have classes on penetration testing or cyber kill chain,
Yes.
right? Response, you know, SIEM, firewalls, all these things, you know. Cyber, mainly the cyber security side. Now the prevention, how to stop that and before it happens, how I can secure my system even nobody can hack it. So that's what. So everything, all these three are part of security engineering. I'm not focusing on these two because that is already covered in some of the other modules. I will focus on how to stop the attack, how to create a secure system, how to prevent the attack. Okay, now let us come to a simple C program maybe. Okay, let's see. Probably it will not be that tough. You can relate with this. I think, yeah. Now, is it very tough? Just two things. One string, I have like one array, character array, buffer, another integer flag symbol. Enter your password. I am taking the password which is entered here. If string compare this whatever is entered with my name, that is the password. If it is not, so string compare what it does, it sends 0 if it matches. It sends some non-zero value if it does not, right? So if it is a non-zero value, then print a wrong password. And sorry. Okay. Yeah. So if the password matches correct password, then flag becomes 1. If flag, then print like print a root privilege given or whatever. The rest of the code. It's a very simple one, right? This is easy. And you understand this kind of code is used in all the software, right? All the applications. Here I have I am using a hard-coded password. Somebody is taking it from a SQL database or somewhere, and the same similar thing is used. Same string comparison, same thing. Here I am using direct string comparison. Somebody might be using hash value of that, whatever. Some little bit complex thing they have done, but it's a underlying thing is the same, right? Even for your Linux system or even if it is a web server, whatever, the same code is fine. Now, if let us run this code. This is the code I'm running it. Oh, sorry. I'm sorry. So GCC, I'm actually suppressing the warnings. This one right now I am using, I will understand why I am using this one. And this is my .c file and this is the output valve. Okay, that's it. Oh, okay, sorry, you're right. Actually, yesterday, last night when I was trying this one, I named it buff2 and I was trying which one is working. So if there is some warning, don't read the warning right now. Now I guess we have this one. Enter the password. My name, I think it should be fine. The privilege given. Now tell me if I just run this one, what will happen? What would be the output? Wrong password. Let's see whether it crashes or not. It did not crash actually. It gave me the root privilege. Why? Let's print flag. What is the value of the flag? It should be 0. Well, it should be 1, right? मेरा उल्टा हो गया तो I don't. This one going. Yeah. Let's print the value of flag. Let's see what's happening here. And D flag. That's how it reads. That's the syntax, right? Yeah. In fact, after many days, I was writing I wrote a C program. I think this is the syntax. Person D and flag. Let's see. Oh, print, not print, printf. Again, it is one. Yeah. Now I'm writing the same thing. This is the value of flag. Now tell me how it can get changed. It is 1. I have the initial value is 0. It's really difficult. You guys have ever tried when the screen is in your back and you are trying to.
So actually you can duplicate the
This. Okay. And file is here, right? Okay. Now here the value is 0. I have set the value is 0 in the beginning, and later it is either it will be 1 or it will remain 0. How we got these values? Any idea? Okay, you are right. That means you have read it somewhere, but you did not understand it fully. Is that correct? You read it something. Okay. I'm explaining that. Okay. Usually what happens when we run a program inside the memory it is nothing but a very big array, random access memory. It does not know whether it is an integer, it is a character, or it is just some memory location, array of registers, right? It just stores 8 bit. That's all. It's a flat thing. Now, we logically, when we create operating system or compiler, logically we think, okay, let us split it into different sections. But in the computer, inside your RAM, there is nothing like that. There is no such section. These are the logical sections. We think in it in this way. So when a program runs, usually the OS kernel is there in the lowest part of that memory. After that, the program starts running. There is something called stack, something called heap, and all the other things. So there is something called the data segment, and heap grows like whenever you are using any variables. Whenever you are defining variable, heap grows like this, and stack is your program segment because every line of your code is actually converted into some opcode, right? The opcode has a specific meaning for the compile for your what is the processor. Processor knows if this is the value, I have to do something, and somebody needs to send those values one after one. Those one after one values are stored here, and the data is stored here. Whenever you are defining any variables, it is here. So stacks grows like this, heaps grows like this, and there is a pretty big section, and it is always logically found that before the compilation starts, during the linking, it actually finds out how much space is required, and the stack and heap is defined in that way. It never get well, like they usually they don't overlap. Okay. Now, what we did some mischievous act here when we apply this one, when we created buff 15 and pass, actually in the data segment, it created only 16, actually 17 byte of space. It knows for running this program, I need only 16 byte, not more than that. And it also keeps some garbage value, some buffer area after that, and then your program segment starts. Program segment is nothing but all the opcodes, which has a specific meaning for the processor. Everybody understanding or fine? Right? Everybody can connect with this, right? Okay. So that's how it works. So in the memory section, what happens whenever I load this one, buff 15, buff 0, buff 1, this we know, but it has specific number like the address, right? This is some 0x2157, then 2158, some random. This is it starts, and from 0 to buff 14, and then starts the pass. It's the integer 2 byte. Simple. Now, when I wrote my name as the legitimate password, this ends here, then 0, then there are 3 garbage, right? And then pass is 0. Fine, no problem. Now, when I give a long one, I never checked what is the length of this buffer. So, what happens? Then there was pass, it actually overflows buffer, right? So, this P and Q together, if you put, you will get actually that number. Everybody understood this? Okay. That's how this is. So now you understood that what is actually happening inside the memory, right? And if you are smart enough, you can actually overlap it with the program segment. By the stack is right. This is heap. Usually the data is in the lower side, and on the top this is the stack. Now, if you are smart enough, you can actually go to this program because after that the program section starts. After this, here the data segment ends, the heap ends, then the stack starts. the end of the program. Then all these things are programmed. Some opcodes should be written. Now, if you are smart enough, you can actually replace those opcodes and you can run your own program, right? So this is how a system can be abused. You can think about abusing a system like this.
So what if we give the label, upper limit?
Then it would not be happy. It would be perfectly fine. So it would, I would check that what is the size of buff. It is more than 15, then I would say that okay, try it again. Like, yes, that's why while I was compiling this one, I had to mention that no stack protection.
But now they are running in isolation, no? Now, next,
Yes, there are now a lot of now operating system handles it, the compiler handles it. So there are kernel level in a kernel level they actually handle using canopy. Lot of things are there.
malloc is also now replaced by some virtual kind
Yes,
of malloc.
yes. Malloc now usually the
They are
coders.
not restricted to that RAM only, both hard disks. can be
Now
used.
think about a scenario when the developers are coding, they are in a hard timeline to chase. They know they have to deliver. Usually C coders mean they are creating firmware or some hardware part, right? Mostly they are creating firmware or operating system, something like that. And we are using all of our are using firmware in our routers, in our laptop, in our monitor. Everywhere there are some codes are written, and those codes are written in C. And just think about those poor developers who are chasing their timeline. Okay, 12 o'clock we will take a break. They have to chase the timeline, and they are writing. So, do you really expect them to remember about secure coding? They know if I write this code, it will work. Now if you ask them, okay, you have to change the timeline, the same timeline. Now you have to make it secure also. That means you have to write few more lines of code for a small segment. Now, if you are writing a stack which is some 3 GB of code, I used to work in Samsung. I remember Samsung Smart TV had, I think, 14 GB stack. The entire C code written, just C code is 14 GB. Remember, there is no video file, no audio or image file. So that is the size of the stack. In fact, there was a huge team of some few thousand developers who used to work on that stack. I don't know who created when they created the stack. Probably usually these kind of stacks are out like taken from some open source things. But somebody obviously created that one, and now there are so many different developers working on that. So if you just tell them that now this 14 I am giving you this 14 GB of code and now make it secure. It's not scalable also. We cannot blame them. It's not scalable also. Because those codes are actually written 20 years back, 20, 25 years back. That main step. After that, people in these 20 years, lot of people have added features, lot of people had changed those codes. Now, if you just go as somebody and say, this is the 14 GB, 14 GB text file, just text file, and change it. It's not possible. So your TV can be hacked, your router can be hacked using this buffer overflow. So there is no proven report, there is no proven data, but it is expected 70 for more than 75% of the hardware we are using are suffering from buffer overflow. Just think this one single one. There are a lot of other vulnerabilities related to the hardware. But just buffer overflow, there are 75% of the.
So for smart TV, if somebody has to do buffer overflow, then he has to enter in the system, right? From internet.
I can purchase my smart TV and I can actually, it is very easy if you know, like in Samsung I know, you have purchased a 30,000 TV and in the 50,000 feature smart TV and the 30,000 rupees smart TV, the difference, there is no difference. Some codes were disabled in that 50,000. The same hardware, everything is there, you will get some new feature. This is connected to internet, this has a browser, this has this thing. That's why we are calling smart TV and this is a dumb TV because it does not have this thing. But everything is there, the same stack they are using, just there are some options you have to enable. So what I did my home, I knew that I was working on that. So I purchased a 30,000 rupees Samsung TV and I know how to change that. I just change all these things, and now it is working as a 50,000. So actually, I made it a 2D to 3D TV.
But it requires hardware also.
Not always. Not
You
always.
remove this chip or how you do
No, no, no. You can like in my
Embedded software, right? So they have certain things.
yes, but you can change the firmware. Always you can. So you never tried your played with your Android phone and you never updated the operating system. Yes, you can use. Yes, you have to change the bootloader. That's all. Once you change the bootloader, you can now put any firmware. In fact, I messed up with lot of my old Android phones. Now this Android is new. This iOS is new one. So I'm not little. I'm
Android is open.
scared to work on that.
Android is open.
Yeah, and Android is open. I do not know the code, so maybe after 2-3 years I will start working.
Possession of the TV. Somebody is in possession of the TV. For internet scenario, how anybody will do for smart TV.
For smart TV,
Smart TV is connected to our home internet.
yes. So what is like when it is connected to internet? What is the difference? Here we are writing, giving the input from my keyboard. When it is connected to internet or any network, the difference is the input will come from the network. So here every input I am giving, it is going to be stored in STDIN. When I am using an internet or any network, the same thing, the same input, the input file will be, I think that is this is standard input. That is I think natin dot yeah natin is a file.
No,
It's the same thing.
at high level, somebody has to hack the Wi-Fi.
Hello.
TV should be on, TV is connected to the home internet. Then somebody can restart it and do whatever.
Yes, they can they can do it. Like whenever it is connected, why we needed network? Because actually long back in 1962-63, what happens? Few folks sitting in MIT, they thought, okay, I have a computer and this University of Pennsylvania, they have a computer, but what that computer does, my computer cannot do. So what I have to do? I have to do some calculation which my computer cannot do. I can just send them the data using your Telegram. I have to Telegram those data, and they take the data and they will run the code and they will send me back the output. Then somebody of them thought, okay, if I am sending to the Telegram and some manual guy somebody is doing it manually, why I cannot connect it directly to the computer? Why I cannot send the data directly to the computer? So somebody used to use the keyboard and do it using the STDIN. Now somebody is doing the, so they thought, okay, there is a file, just a simple file, standard input file. Instead of standard input file, I can use some other file, and that other file will be filled using network. That time they thought about this telegraph, then the telephone came, then they thought of the telephone connection, then they started circuit switching to packet switching, and then the entire thing comes up, and then, but the main intention was that, and now also like this, Google server, Google computer can do something different that my computer cannot, because they are running some other software or some application that I cannot do. What I do, I just connect to Google and send them or search me about this particular phrase. My computer cannot do. You have data, you just give me that data. That's all. If the same software, if I have infrastructure, I can run that same thing on my computer. I don't need it, you don't need any network. I can check anything. Right? It's the same thing. So, whenever you are connecting to internet, it is the same attack surface. The same thing you can do, but you can do with your computer. Yeah. The hardware part or something you need physically replace something, that is not, that cannot be done. For that you need physical.
This is the no risk for Samsung. They would be aware.
Samsung doesn't see it as a risk, and now they have done like buffer overflow is easy nowadays. It is easy to mitigate, but still people don't do because of the performance issue. Because now the operating system, I just need to update it in the operating system level.
But with this technique, I think it's more cost effective.
Sorry.
With this technique, I think it's more cost effective because you have one software, multiple things, you just need to disable it.
Yes, that's how people thought. Like 16 GB or 14 GB of code they cannot handle, so I am handling it in one level up. That's simple. They did it, but those threats are still there. Buffer overflow threats are still there, but they mitigated the risk, or they mitigated the threat in one level up. That's how it works. Actually, yes, because lot of bugs like I know about Samsung and it's same for almost all the hardware, like all the electronic companies, because time to market is so less. Now I like if I really want to work and make it totally bug free, secure, vulnerability free, by that time my competitor companies will launch 10 products. I cannot miss the market. So the TTL is sometimes I can remember I come up with a new feature that I patented and then I wanted to put it into the TV and the time I got is around 30-35 days. It's a totally new feature. So 30 days I have to write, like me and my team had to write the code. The testing team would test it and then it should go to the go to the factory. Same code has we had to pass that thing in 35 days. That was the deadline given to us, and that is pretty much everywhere. Any consumer electronic market, the Android phone or TV or whatever. That's why they same patches, and that's why you will get lot of buggy products. Yeah, that's why you relate because because one feature Samsung knows if I don't launch this feature today, tomorrow some other will launch the same feature. And then I have to go to court, I have to drag them, this is patent is in my name, then these guys will say, no, we have a different patent, all these things. Better first push it in the market. Then whatever happens, happens, you'll see. That's all. And that is business, that is how the market is. Okay. And now it is called buffer overflow and the same thing, exactly the same example that I have given, it was there in a Microsoft Windows 7, the SME server. The same thing, and for that, this was the loss for Microsoft. Okay. So you can see there is no array bound checking, just the string checking was there. Now if somebody just does not put this null input like this null character, it simply goes in infinite loop and then it actually changes the buffer. So using assembly server, you can actually root any Windows 7 system. And then Microsoft literally had to beg everybody, please update this assembly server. Assembly 2.0 is now deprecated. They had to literally beg everybody, please come up to assembly 3.0, otherwise it will be a huge risk. Okay. So this is how we can. Okay, now we can take a break, and we'll start again with the next. So this so far we saw how a system can what can go wrong with a system with the live demo we saw it. Now it is easier for you to understand like how a buffer overflow can happen and how using that simple technique actually lot of the systems, in fact many SCADA devices are also suffering from buffer overflow.
DNCs, SCADA.
SCADA, yeah. Many SCADA devices have this one, and SCADA really cannot update their operating system so often. It's more difficult. Yes.
Patching has to be digital, no? So it is digital.
Almost are very old. Almost are very old.
Yes. In fact, most of our routers, I don't know how many of you have updated your router firmware. It never, but actually you should.
192, 168.
Usually every 2 years they come up with new patches and all, right? You should update that firmware, otherwise it is very vulnerable. Yes, there are some things because we are also, even we are security engineers, we are into security things, but we also sometimes how many of you have the same password for every portal?
What?
Same password for every portal. How many of you use the password? Reuse. That means all your bank account has the same password.
No. But I have a pattern.
If somebody knows the pattern, they know. Like
Which are not critical
yeah,
websites?
like my bank name or my bank debit card number, the pass number, and then phone number, whatever. I'm not asking that, but yes, there are something. Srini, are you there? Okay.
Yeah.
Sure. Now we are going to take a break and we'll come back. Thanks.
Thank you.
Because zero trust is a different thing. Zero trust is a designing tool. Right? Now I design a zero trust system, but I still might have a buffer overflow exploit. Right?